In today's lecture, we will start with the electronic ignition system. The engine ignition system exists solely to provide an electric spark to ignite the mixture in the cylinder. The engine performance is strongly influenced by the spark timing relative to the engine position during the compression stroke. The spark advance, that is relative to the top dead center, is determined in the electronic engine control based on number of measurements made by sensors. The optimum spark advance varies with the intake manifold pressure, RPM, and temperature. However, in order to generate a spark at the correct spark advance, the electronic engine control must have a measurement of the crankshaft angular position within an engine cycle. The engine position measurement is determined by a sensor coupled to the camshaft and another coupled to the crankshaft. Electronic ignition can be implemented as part of an integrated system or as a standalone ignition system. So this is a control diagram where there is a input taken from an engine position sensor, RPM sensor, MAF or MAP sensor. Input goes to the controller, then according to the control algorithm, trigger pulses are generated, which goes to the driver circuit, and through driver circuit it goes to the spark plug. Based on measurement from the sensors for engine position, mass airflow, manifold air pressure, and RPM, the electronic controller computes the correct spark advance for each cylinder. At the appropriate time, the controller sends a trigger signal to the driver circuits, thereby initiating a spark. Before the spark occurs, the driver circuit sends a relatively large current through primary of the coil. When the spark is to occur, a trigger pulse is sent to the driver circuit to interrupt the current in the primary. A very high voltage is induced at this time in the secondary coil. This high voltage is applied to the spark plugs, causing them to fire. In those cases for which a coil is associated with two cylinders, one of the two cylinders will be in this compression stroke. Combustion will occur in this cylinder, resulting in power delivery during its power stroke. The other cylinder will be in its exhaust stroke, and the spark will have no effect. Most engines have an even number of cylinders, and there can be a separate driver circuit and coil for each pair of cylinders. Now, in the upcoming lecture, we will discuss about the idle speed control system in the electronic engines.